Hey there! We've been looking into the ancestral technologies of audio, and already we've covered the phonograph, which provided the world with a storage medium for analog signals or sounds that are allowed for recording and playback of speech, sound, and music for the first time in history. The phonograph was invented in 1877, however, was entirely mechanical, and this made any kind of amplification or transmission of these audio signals outside of this acoustical realm impossible. So until that scratchy, thin sound could be enhanced by the new power of electricity and transformed into an audio signal that could travel inside of a wire of cable, it was just going to be another toy, a little sophisticated music box for personal enjoyment, and not that much more than that. But the good news was that the late 19th century was a very heady period for invention, and there was groundbreaking happening all the time. In the middle of it, of course, Thomas Edison, you've heard a lot about, I'm sure. He found a lot of early success, especially in the beginning with the incandescent light bulb. And he took the resources from creating that and plowed that into expanding more access to electricity, and then, of course, trying to figure out some commercial devices in which to use it. In fact, Edison was really involved with getting electricity to the people. You've probably maybe even seen the movie about Edison and Tesla, but if not, you may have heard that he got backing from J.P. Morgan back in 1882 to launch what became General Electric. And up until then, any electricity was privately generated, but that was beginning of having electricity becoming available to everybody, and so naturally we had to find some way to use it. The previous technology to telephones, leading up to the telephone, would be, of course, the telegraph. And the whole idea of telegraphy as we know it, which is sort of a binary kind of a communication format, the whole idea of that made its original debut in France during Napoleonic times. They used to do optical telegraphs, put these devices on these towers, and a gentleman by the name of Claude Chappe in the late 18th century figured out a system of communication, and you could get a lot of information across the France countryside from tower to tower using this semaphore kind of communication. This kind of sort of binary and very simplified communication became desirable to do in an electric format. It's a fairly straightforward idea that we're talking about here, which is you have an electrical circuit, you put a little bit of power into that circuit, somebody in that circuit can interrupt the circuit, can break that circuit, and they can send a coded message through that, and then somebody that's also part of that circuit on the other end of it can perceive the breaking of the signal and the code that is embedded in that, and you can do thus very, very simple and effective communication at a long distance. This led to, of course, the electrical telegraph becoming more of an official thing, starting in the mid-19th century. You had, in Britain, you had Cook and Wheatstone patenting their device in 1837. The problem was their system required two wires to be strung between all these different places, where meanwhile, the US system that was being developed by Samuel Morse was using one single wire. So what ended up happening with that was that Morse was having a lot of success in the United States. He ended up connecting Washington and Baltimore on a line in 1844, and then later was able to connect the east and west coast of the United States in 1861. So this sort of tipped the things in his favor, and his code and system became adopted as the international standard in 1865, with Western Union becoming the lead provider. So the telegraph business became quite an industry unto itself. It became a priority to improve the telegraph. And in fact, Edison's invention of the phonograph sprang, as we found out earlier, from his wanting to be able to record multiple telegraph tones so he could send that to multiple different people without having to do the message over and over again. Then the idea of speech actually became a bonus for him. We started to see real potential in these telegraph lines. This was a way to pass a signal over long distances. And one person that really thought about that a lot was Alexander Graham Bell. It was a man whose mother was deaf. His father was a teacher of elocution. That means someone who teaches people how to speak properly. And he had developed a phonetic transcription system to help deaf people learn how to speak. The father imparted this interest to the son, and they were trying to figure out how they could make sound be somehow, quote unquote, visible for the deaf by using the telegraph line system. Bell was not college educated, but he was able to use his talent and his father's connections to open the School of Vocal Physiology and Mechanics of Speech in Boston in 1872, and then he became the professor of vocal physiology and elocution at the Boston University School of Oratory, all at the very tender age of 26. So he may not have been college educated, but he was definitely an intelligent person. But what he was working on in 1871 was what he called a harmonic telegraph. And the idea of this was to allow multiple messages or frequencies, in his case, multiple frequencies, to be transmitted over a wire at the same time. He came up with a simple receiver that could render this in 1875, and then he had the fortunate backing of Boston attorney Gardner Green Hubbard for his venture. And this is significant because A, Bell married Hubbard's deaf daughter, B, Hubbard wanted to break the control of Western Union, and C, Hubbard really saw real potential in this technology. As a result of this, Bell was granted the patent for the telephone in 1876. This is actually kind of a point of real controversy, as it turns out, though. A lot of us sort of hear about how Alexander Graham Bell invented the telephone, and there's the whole, Watson, come here, I need you, and he hears it and comes in, and there's this whole mythology that's been built up around the invention of the telephone. But there's actually a little more controversy to it than that. There's actually two other people that can make the claim that they have also invented this technology. Antonio Meucci, I hope I'm saying that correctly, he invented his teletrafono long before this even happened, and his materials vanished without a trace from the laboratory that Bell was also using at the same time at one point. Oh, then Elisha Gray, another inventor, he was working on the liquid microphone, and he submitted his patent application the same day that Bell did. And in fact, we find out later that he submitted it before Bell did, first thing in the morning when they first opened up the office. However, Bell's attorney, who brought his application in, insisted on paying the application fee immediately, and guess what? That got him the edge. So Bell got his in before Elisha Gray did. That's business, people. That's how it works out in the real world. Things really happened very quickly after this patent happened. 1877 and 78 saw the first telephone line constructed. We had the first switchboard created, the first telephone exchange come into operation, and within 3 years, 49,000 telephones in use. And then in 1885, American Telegraph and Telephone Company, AT&T, formed. And by 1900, 600,000 phones. 1905, 2.2 million. 1910, 5.8 million. This was really picking up speed. In 1907, we found out that AT&T had a monopoly. Big surprise there, because it had actually purchased Western Union, the big telegraph company that was their main competition. This got a lot of people kind of hot about it in the legislature, though. And in 1913, AT&T had to divest itself of Western Union, which was at this point a shell of its former self. They got out of the long-distance business because the antitrust sentiment at that time was pretty strong. But AT&T still maintained a pretty strong monopoly for years after that. That's a whole other story. So let's talk about the device. How did it work? Bell had built a device originally called a phonograph. And what's really bizarre about this, and macabre really, is that he made it out of a dead man's ear. And speaking into this device would cause the ear to operate like an ear does. The ear's membrane vibrated according to the intensity of the voice, more for louder voices or sounds, and less for quieter sounds or whispers. And this in turn caused the lever attached to the ear to write a wave pattern on smoked glass. Bigger waves for louder sounds, smaller for quieter sounds. And seeing these patterns in the glass inspired Bell, and he thought, well, maybe just by using a membrane to convert these sounds of varying intensity into electrical current of varying intensity, instead of just working this lever and then reversing the process on the other end with another membrane, he could replicate speech over long distances. And in his first working telephones, he used the liquid microphone that Elisha Gray had been talking about as well to create this variable resistance. You would speak into this tube pointed downwards, and this would cause a metal membrane to move and vibrate according to the intensity of the sounds of your voice. And then in some models, the membrane was further attached to a little steel rod, and that would be pushed down and pulled up by the vibrations, and the rod would move up and down in a cup of electrified acid water. which is why you had to speak downward into it. And this would then change the resistance, which would cause a fluctuation in the voltage. This would send a variable current out through a wire to a receiver on the other end. Well, as you can imagine, this kind of had some problems with it. I mean, trying to yell into a cup full of acid water, I don't know. The human voice really couldn't create enough power to make this happen, though. And a call over a few miles was really hard to do, so even with the magnets. It was important to come up with a new transmitter, and 1877, Thomas Edison comes to the rescue, designs and patents one utilizing the special properties of carbon. Carbon changes its electrical conductivity with minimal amounts of pressure. Pressure such as that created by pressing a membrane against it. A membrane that is vibrating due possibly the sound waves created by a human voice. This allowed the same basic setup as he had with the liquid microphone, but without the difficulty of using a cup of battery acid, and it had a lot better capacity when used with outside power to get more distance and clarity in the line. And this carbon microphone was used for many, many years, and you'll probably still find one if you got an old handset, old school rotary telephone, which I'm sure very few of you have even seen one of those in person at this point. The carbon microphone was the first manufactured device of this nature. It was also very inexpensive, very durable. The only problem was it had very limited capabilities for frequency response, and that called out for improvement. So that means a lot of investors took up that challenge, and we ended up with a microphone industry, which is for another time. From the beginning, copper wire had been the carrier of choice. In the telegraph business, you would have the wire going from one place to another, but then there was another wire going to ground to complete the circuit. One of the problems of that was that since everybody was going to ground in their circuitry, this created static in a lot of the systems, and so this needed to be fixed by having a two-wire metallic circuit starting in 1881. One that goes to your friend and one that comes back to you. This created a complete circuit. Didn't have to be grounded by the earth, but it meant we had to replace all the telephone wires we'd already been running up till then with two-wire systems. So they did that by 1900. They could now carry whatever analog signal could be captured and reproduced on both ends. Then in 1877, Thomas Doolittle of Connecticut comes up with a process for hard-drawn copper wire, and this increases the tensile strength. This allows us to have overhead wires insulated with cotton impregnated with paraffin, gutta percha or rubber, and later with PVC. And then by the late 1800s, we started realizing we needed to have these pairs of wires in twisted pairs because this would provide some protection against picking up interference from other wires and other electricity nearby and from general interference. And this technology, of course, went on to be the cabling technology that we have used ever since in audio for all audio applications. This is where it started. The immediate result of all this technology, of course, well, instant spoken word communication connecting the world. That's a pretty big deal. We could do a full semester on the social consequences of the development of communication by telephone, but we're not going to do that today. We're just going to talk about the long-term results for audio. The main one, of course, is that Bell established the ability to transmit potentially frequency-rich waveforms, or what we would call analog signals, as a constant series of voltages through electrically charged wires and cables. These voltages of the signal vary continuously with the pressure of sound waves captured by a microphone. And that is now a technology unto itself. To be perfectly honest, the invention of the telephone did not have a direct effect on any popular music of the time, except maybe that people would call each other and talk about a great song they may have heard at a concert or performance. But almost all the audio technologies to come from the research done by Bell and Edison have gone forward. Even the digital technologies come from improvements to the switching systems for telephones. That's a binary system. It's either on or off. It's going in or it's not going through. It could literally play any recorded music that used electricity in any way, and it would represent this technology. So take your pick. What's actually pretty darn fascinating, though, in my opinion, is that how we've managed to come full circle to the point where instead of using technology that's influenced by telephones, which is what we've been doing for 100 years or so, we actually now can use our new phones or smartphones to write and record music and send it instantly via satellite to almost anywhere in the world. All you need is a phone. It has a microphone, musicians, recorders, mixers, masterers, transmitters, and social promotion departments all in one box. But you know what? We're going to save that for later in the semester. We got somebody going to give a presentation about that later. So that's my explanation about the telephone. Obviously, we could get much more technical about it, but it really is actually a fairly straightforward technology that gave birth to all the possibilities that we've been able to enjoy ever since. The simple fact that we can listen to music on a device all starts with the fact that we got acoustic sounds to change into voltages that are carried in a wire or a cable and are reproduced by a receiver at the other end. That's my discussion about the telephone. I'm looking forward to seeing some of the presentations coming up. Next up will be the vinyl disc. And for those of you who have presentations upcoming, be sure to reach out to me if you haven't already to get resources and pathways for your presentations. As always, I'm here to help out and to talk to you if you need it. Take care.